For this week, most of you are working on the project that is for moving a character on OLED by using the potentiometer. And many of you asked about how you can work with potentiometer and how exactly it works. So I'm going to show very simple example how you can read the information that is coming from potentiometer, and I will explain a little bit how you can associate different positions on the display screen according to the values that are coming from potentiometer. The potentiometer is the component that looks like a knob on your board, and in first part of this video I will discuss about how it is working, and then I will show the hardware when I upload one example code, and I hope this helps. Okay. Here on Google, if you type Grove potentiometer, many of you might say potentiometer. For me, it is potentiometer. Sorry if I don't pronounce it well. Now, the first link that comes up, this is the component that you see on your key. And then there is good source of information here explaining how it is working. And whenever you are dealing with Grove Arduino kits, you see this word. It is a rotary angle sensor. Makes sense because it is measuring the angle. When you are turning it to the right or left, it is directly related to the angle. And inside this component, there is a resistor. So the value of that, the resistance of that component is directly related to the angle that you are turning it to the right or to the left. I will explain further in a second. Here there is one example, and it is using a different type of Grove kit. As I explained before, you don't have to be worried about wiring because your kit has built-in PCB. We are going to use the example that is given on this page, and I modify it a little bit to make it compatible with our kit. Now here is the example. You can see that the rotary angle sensor is defined here, and then you have the serial port connected by using this function here, and then you have this formula to calculating the voltage that is being measured based on that angle that is coming from that sensor, and then you can print it on serial port or plotter or the monitor. Now I'm going to copy this, and I'm going to open my Arduino IDE, and I make a new file and replace that with this new code. I just check everything is okay, and the pin number should be changed. It is defining the sensor, and it is using pin A0. For us, that would be a different pin number. For finding out what would be the proper pin number for us, I would go to the website beginner.seed.cc. Okay, this is the page that we come all the time to get information regarding our hardware. Now, coming down to find the table that has all the information about the addresses and interfaces. Here you can see that we have information for the modules and components, and then the interface in the middle is described, and the pin and address number. So here the rotary potentiometer is analog and makes sense because we don't have only 1 and 0, high and low. We have analog value, variety of numbers coming from that sensor, and it is using the pin number A0. So we are lucky we don't have to change much about that code because it is already A0. The LED, because that example, if I'm not mistaken, is changing the brightness of the LED. Now I'm checking the LED. For me, my external LED, and for you guys also, because we are all using the same platform, would be D4. So I'm going to change that address to 4. All right. Now things are fine. I'm happy with my voltage and stuff. Now I'm verifying my code. Potentiometer and potentiometer. Did I pronounce it correctly? All right. Okay. And here we go. I'm uploading it on my code. So what is happening in this code? I'm just quickly looking at the code. We have the values coming from the sensor stored in this variable, which is called sensor value. And then there is this calculation done for calculating the voltage. And then the value is going to be printed on a serial print. I can open the serial monitor and look at the numbers that are coming. Right now, the position is on the very left side, and I'm going to change it slowly to the right side. And as you can see, that value 300 is coming down. It is coming down and it goes as low as 0. So that is when my potentiometer is on the very right side, at the end of right side. That is the value that is coming. Now, looking at the plot sometimes helps more. So I'm going to look at the plotter. Now, the plotter was showing 0. I increased it. I go up, down, up, and down. And I'm going all the way to the left side. I want to see what happens to these values that are coming when I have the potentiometer on the very right side. You can see that I'm stopping at 300. And that will be the constant value. Again, if I'm moving it to the right side, the value will drop. The reason it is dropping is because of that formula that I have, because I'm measuring the voltage. Yeah. So if you want to use this code for having the range for positioning your character on the LED, you can use the range from 0 to 300. I advise you to have another formula for dividing this range to only 10 boundaries. That means that if my highest value is 300, then by dividing to 10, it will give me the number of 30. And then your range will be reduced from 0 to 300, to 0 to 30. So that will be a bit easier to deal with. Now, this example has another part at the bottom side, and it is defining a variable called brightness. And the brightness is mapping the degrees and there is another one that is here for full angle. So using this function, we should be able to change the brightness of the LED, because we are using analog, right? So we can have variety of values in front of LED, and instead of having digital, right, we normally deal with digital, right, for LED. In this case, we have variety of numbers passed to LED. So it means that we can change the brightness of LED by changing the potentiometer from the very right side to the left side. Now, this is about potentiometer. You can run the program and you can see it on your kit how it works. Small explanation, I need to discuss a little bit more about the way that potentiometer works. Now I'm going to use some of the PowerPoint tools to explain that. So inside that knob, we have round resistor, and this resistor, let me grab a pencil, something that I can draw. Okay, so this resistor has sorry for my drawing, but it has a shape like this. I'm going to make that more visible, and hopefully that explains it. The color is not good, so I'm going to pick some very visible color. That is better. Now, the voltage is given to one side of this bendy resistor. Now another side is I don't know what I drew there, but let's make it nice and bright, and I zoom in. Alright, so that would be the center, the knob part that I'm able to actually move around. Now this arrow that I'm trying to display, which doesn't show at the moment because of the color, so this arrow will be like a clock handle, and if I put it in a way that can touch the resistor, this is a simple representation. Is not going to be exact same as, you know, if we open that circuit up, you probably see something that has nothing to do with this diagram, but I'm trying to explain it in a very simple way. Okay, so another side of the cable is connected to this one here. So if I have my my voltage, oops, I don't like that, I don't like it. If I have my, let's see, my my voltage given to these two, all right, one of them is my positive, another one is for my negative. Okay, so the complete circuit will be by connection of these here. So the current is flowing from this line here and from through the arrow and come back to the negative side of my you know, the source, power source. So if I have that arrow at this position, if I have it at this position, my resistance will be very, very small. It looks like a shortcut. And if I just turn my knob in the middle or somewhere here. So I'm going to have half of total resistance measured in this signal, in this system. So the current flows from here, sees some obstacles, some resistance, and goes from here and comes back to the source. So I'm going to have half of the resistance that the maximum resistance of this potentiometer has. Now, if I move my knob all the way to the right side, at this point, I'm going to see the maximum resistance from that sensor. The reason we are calling it rotary angle is because we are dealing with angle. We are moving it around this angle. So I'm having something close to 300 angle. Depends to how the hardware is actually designed. This angle can vary. But I hope now you understand how that knob is related to the voltage that we're calculating in that example and the resistance that is directly related to the position of that knob. Now, for the project, what I want to happen is to have that knob linked to your display screen. Now I explain a little bit about that. So if I imagine this is my display screen, so in this case we are dealing with OLED 0.96 inch and it is a Grove OLED display screen. You know basics of how to display text and variables on the display screen. This time you are going to control movement of a character or a shape on the display screen. Now if I let me draw one star here, for example. Again, I have to use some bright color to make it visible. Now, I'm just zooming in a tiny bit. All right. Now, if I have my knob, if I have my potentiometer, oopsie, sorry for that. If I have my my potentiometer at the very left side, I want your character. Okay, start from your initials, just 1 or 2 letters. Start from that, and once you're happy with the movement, then you can move and do it more fancy, make emoji or whatever character you like. I'm putting a star here, okay? So at the very left side, when your knob is in that position, I want your character to be on the very left side of your display screen. It doesn't matter this line, or this line. We have limited lines anyway. So that means that the value that is coming from that potentiometer, based on what we saw on the plotter a minute ago, it will be a 0 value. So that 0 value should be directed to the position that is given to your display screen for displaying that character or that letter. Then when I'm moving it, oh, please. Now when I'm moving it to the middle of the area that I have for potentiometer, the character moves and comes to the middle of this display screen. Now if I move that all the way to the right, so the character should come all the way to the very corner side, and then again, doesn't matter if you're choosing this line or whatever, you know. Even if you like, you can move it this way. It's fine with me, okay? I just want you to learn and understand how exactly you can relate the value that is coming from your potentiometer to the position of your character. Now, the value that is coming from that Grove potentiometer, the highest value will be 1023. So altogether from 0, it will be 1024 numbers. If you want to use the example that I just explained on the IDE, that code is using that formula for calculating the voltage. And that voltage varies from 0 to 300. It's up to you which way you want to use. You may come up with your own formula. You may divide the 1024 by 100, and then you can have a range between 0 and 10 or 11 or 12. That means that you have 10 or 11 different spaces here, and then you vary them based on the input that is coming from the potentiometer. Okay, I hope this helped and everyone managed to do a fun project. Thank you. Good luck.